Okay, today we're going to be talking about inverse relations and functions. And let's go here to our essential understanding, which is the inverse of a function may or may not be a function. And this diagram, do you remember back in Algebra 1 when we did mapping charts, where we mapped x values from the domain to the y values in the range? Remember, the domain is x and the range is y. So remember that as long as each x value only goes to one y value, this would be a function. So this right here would be a function because each x value only goes to one y value. But the inverse of that function just means exchanging the x and the y values with each other. So this is now your domain is these two values, and your range is the four values, and you can see that each member of the domain is now not going to just one y value, but going to two. So this is not a function. And so what this is going to set up for us is we need to learn about inverses in order to be able to graph radical functions, because radical functions are inverses of quadratic functions. All right, so first of all, we're going to do an example where we find the inverse of a function. So here is our relation. These are our x values. These are our y values. And what we have to do is find the inverse. And so the inverse would look like this. Make a column for the x values. You'll love this because this is pretty basic. And a column for the y values. And here's what you're going to do. All the y values become the x values. And whatever x value they were matched with now become the y values. So that's creating that inverse is as simple as exchanging the x and the y values. Okay, we can also do this with a graph. And right here I have a relation, and what we're going to do is draw the graph of the inverse. Now, the inverse is the reflection over the line y equals x. So I need to draw that line, and so I'm just going to put some, remember you start at the origin, go up 1 over 1, up 1 over 1, and I'm going to get a line here. And I'm drawing in this line, and I'm going to draw it dashed because we don't need it there for anything other than to help us draw this graph. But this is the line y equals x. Okay, now the way that we're going to draw the inverse of this is to reflect our 4 points here to the other side of this line. So would you agree the other side of this point is right over here? You see that? And if you look, it's the same distance on both sides of the line y equals x. And it's also very similar for this point. We're going to put it right there and see how it's an exact reflection over that line y equals x. Now, this guy right here is going to be over here. But look at again. When you connect them and you see it's exactly the same amount on the other side of the line y equals x. And here's that one. So in red is where you have your inverse on a graph.
So is that how you put the answer?
That is the answer. It said find the inverse. That is the inverse. Do you want to write the points out? You could say that. So if we want to write the points, we have inverse. And this is the point -1, 0. 0, 2, and and then I've got 2, 3, and 3, 4. But the graph is all you need. Okay, the next thing we're going to do is we're going to do the same thing, find an inverse of an actual equation. And we did this in Algebra 1, so this should not be brand new to you. And what we're going to do is exchange x and y. So let's write our strategy here. So first of all, switch x and y. Okay, would you agree this example is a quadratic function, right? Because it has x squared. It's a quadratic function. Okay, so switch x and y, and when you do that, here's what you'll have. X equals y squared minus 1. Agree? Next thing you need to do, solve for y. Okay, so that's your step 2. We'll write that out. Solve for y. Okay, so first thing I'm going to do is I'm going to add 1 to both sides because I need to get y by itself. So I have x plus 1 equals y squared. To get y by itself, I'm going to square root both sides. And the square root of y squared is y. And over here, remember, we do have 2, 1 plus, 1 minus the square root of x plus 1. Now, here's the cool thing. Let's go to our Desmos, and we're going to put both of these in there. So here's our Desmos. And what was our original function? Y equals x squared minus 1. So y equals x squared minus 1. There it is. And let's put in that line y equals x so you can see it. So y equals x. There it is, blue line. So we're going to reflect our parabola the other way. And remember, wasn't this, once we did it, y equals, hang on, where's square root? Oh, there we go. Square root of x plus 1. And notice, they intersect right on that line, y equals x. But what it did is it took this part of it and reflected it exactly over this line, y equals x. So you found the inverse, all right? Now, if we want the other one to finish it off, we can do that. So y equals negative square root of x plus 1. Now you've got them both. And now see how it is exactly the inverse. It's the exact reflection over the line y equals x. Okay? All right. Let's do another one just for the sake of getting it done here. Same steps, switch the x and the y. So I have x equals 2y plus 8, solve for y. So subtract 8 from both sides, and I have x minus 8 equals 2y. Divide everything by 2. And I end up having y equals 1/2 x minus 4. All right, those are inverses. And if we want to go to our Desmos, let me get rid of some of this stuff here. And let's bring it down here. We've got y equals 2x plus 8. There we go. And what was the other one? 1/2 x minus 4? And see how it is an exact reflection over that line, y equals x. Okay? So that's finding the inverse of a function. Next thing we're going to do is we're going to graph these. So we kind of already did this on Desmos. We graphed these on Desmos. And if you recall, we know how to graph the function y equals x squared minus 1. Remember, this right here is our y-intercept. It takes our whole regular graph and shifts it down 1. So right there is our vertex. Up 1 over 1. Up 4 over 2. So there we go. And what we're going to find out is when we rotate this on the line y equals x, let's draw that in. When we graph in, need a new color, there we go. It's going to cross right here. There we go. And I'm just doing that kind of freehand. I know how to graph the quadratic part, right? And we also did this second one. We did this on Desmos, so I'm going to save you from doing that one right now. We did this on Desmos. Look, it's very easy. Turn it on its side. You have your vertex here. Here's up 1 over 1 right here. Up 2 over 4 right here. Okay, next page. Now, what we have to talk about is finding the domain and the range. And remember, we already did this when we were doing just individual points. You remember that finding the inverse of a function means the domain and the range get shared, or switched, don't they, right? That was switching the domain and the range, was taking the inverse of a function or a relation. So, that's what we're going to do. Okay, so what we want to do with this is a radical function. We know that the inverse of this is a quadratic function. Let's find that inverse. So here's the, we'll find the inverse right here. F1, or negative 1, means the inverse of f. So that's a notation thing. So here's what we're going to do. We're going to take this is a y, and we're going to switch it. So I'm going to have x equals the square root of y minus 2. The way that we get y by itself, you know this, square both sides, and I get x squared equals y minus 2. Add 2 to both sides, and I get y equals x squared plus 2. So there's the inverse. Now, this is easier. We know how to find the domain and the range. This is a parabola, right? Would you agree? The domain is all real numbers, right?
Yeah.
Domain is all real numbers. Okay. Here's the range. What is the range? Does anyone remember how to do this? This is a parabola.
Isn't it like y is greater than or equal to?
Greater than or equal to
1.
2.
Oh, whoops.
Because remember, this is a parabola where the vertex is, it's upward pointing where the vertex is on the point 0, 2. So 0, 2 is the lowest point. So y is greater than or equal to 2. Okay? Now, the domain in the range of f should be switched from this. So we would say that the domain is y is greater than or equal to 2, and the range is all real numbers. Okay? We'll see how this goes. So first, let me tell you a little trick about these wonderful radical functions. You can't have a negative under here, can you? You wouldn't think so. So x minus 2 has to be greater than or equal to 0, which means x is greater than or equal to 2, right? And x is our domain. Now, I want you to take a look at something. Let's put this graph back on here. So we just determined that the domain is x is greater than or equal to 2, which means everything from here this way, right? What the heck is our range? I mean, just looking at this, let's think about this. Let's think about this. First of all, this just stops right here, right?
Oh, y is greater than or equal to 2.
Think about 0. Why is this?
Oh,
It's greater than or equal to 0. Y is greater. This is going to keep going up over here. I mean, if you keep on going to infinity and beyond, it's going to go up to infinity eventually. But our domain, or our range here, is not all real numbers. It's not. Because if it were, it would have to be this. Now, that is not a function. Would you agree? Vertical line test. This is not a function. Okay, so let's go back here. Our range is y is greater than or equal to 0. So, we've got a lovely little thing here. The inverse of a function f, denoted by f to the negative 1, which is f inverse, or the inverse of f, may not even be a function. The actual inverse of f is a function, whereas its inverse is not. And the reason why, we can only have half of it. It fails the vertical line test. All right. Let's go down here to, nope, skipping the last thing. That'll be it.